Hello and welcome to eCHO. I believe this is episode 181. It's in the evening my time. It's in the sort of more US friendly time zone. Duffy is traveling right now, so I'm standing in this time zone today. If you're watching wherever you are, it would be great to get comments, to know that you're out there. And who knows, I might need some help with this because I'm flying solo, and I'm going to be trying out a tool called bpfilter. So I can't quite remember why this kind of crossed my consciousness in the last week or two. But when I realized we needed content for the show today, I remembered seeing bpfilter and thought, yeah, I could take a look at that. I've been playing with it a little bit on the last couple of days, and I want to give a big shout out to Quentin Deslandes, who is the maintainer of the project, and he's been super helpful helping me get up and running with this tool. Amazing. We've got the first comment. So hi to Gassan. Nice to have you with us today. If you're a bpfilter expert, fabulous. So what I've got on the screen here is some slides from Quentin's talk at Scale. I think this was last year, and where he talked about bpfilter. I think a simpler and faster firewall is a really nice summary of what it is. Quentin is a software engineer at Meta. As you may well know, Meta has been a long time user of eBPF. Alexei, who is one of the originators of eBPF, is at Meta. And I believe I've heard somewhere that every single packet that goes to any of Facebook's products has been going through eBPF since 2016, which is pretty impressive. So what is bpfilter? A simpler and faster firewall where essentially, rather than using IP tables rules or maybe NF tables rules, instead those rules are written in the form of BPF programs. I think I want to use a different presentation here from the year before, where there's a little bit more background that Quentin gave about what all these rules are for. So IP tables has been around since, the last century, the end of last century. And it defines these, or you can define these rules that if a certain condition is met for a network packet, then it can be dropped. Or if a certain condition is met, then it can be accepted. So for example, if it's from a particular IP address in this example. And IP tables rules are also used to route packets to different destinations and so on and so forth. Here's another message. Hi from Joseph. Nice to have you with us. Nice to see you. I'm loving how everybody's putting bees on their hellos as well. That's great. Okay. I'm going to skip over this slide. There is a nice, I like this comment as well. Let there be eBPF. And I think somewhere in this slide deck, there is a nice, this will describe it, I think. A nice description of what's happening in bpfilter today. Actually, I will give a little bit of background. When I first heard about this, I was a little bit confused because I thought bpfilter was something inside the kernel. And there was an attempt to kind of convert, or to my understanding, there was an attempt to convert things like IP tables rules into BPF programs within the kernel. And that change actually ended up being never really sort of fulfilling its promise. So now bpfilter is a daemon. I'm going to show it to you shortly, and some kind of client that uses this libbpfilter to generate BPF programs that the daemon then loads into the kernel and attaches to whatever eBPF hook point we're interested in. Okay, how about I try and play with this a bit now? So here's my terminal, and hopefully I can, yeah, okay. So actually, why don't I bring up the instructions first? So this is the bpfilter website, and there's a little bit of nice background here about what you need to do. Start the daemon in the background, and then we're going to use a tool called bpfcli to create the rules and to manipulate the rules that bpfilter is using. So you can see there in the kind of animation, the BP filter being run in the background, and then a ping being attempted, and then using a rule to block those pings. Right, so let's do that. I should probably also mention that I basically built the source code, or I built this from the source code, and that worked absolutely seamlessly, which is really nice. I think quite often when you pull a project from GitHub and you try and build it yourself, it's really painful. And actually here it was super straightforward. So kudos to Quentin for making that nice and easy. So I need to run the bpfilter daemon. And I'm going to run it in what's called transient mode. And what this means is, or if this isn't there, then if I define rules, they'll get pinned to the file system and they'll persist over stopping and starting the daemon. But this way, whenever the daemon stops, it's going to bring down the rules as well. And I'm also, for fun, going to put in some verbose flags so we can see a bit more what's going on in the daemon. So debug, I think, just generates some information as we go along. Going to put BPF, which I believe from the documentation passes any logging. If there's a log inside a BPF program that would normally go to the kind of tracing pseudo file, the kind of thing that you can see with BPF tool prog tracelog, that will pull those trace lines into the output from bpfilter. And the last thing I'm going to add, the last verbose flag, is bytecode. And this allows us to see the actual BPF program bytecode that gets generated from the rules as we define them. So I'm just going to run that in this terminal and leave it running. And as we manipulate the rules, you'll see some interesting things. Well, I think they're interesting things appearing in this output log. So if I just run bpfcli, it's going to tell us it needs an object and an action. Let's also look at the help for that. Okay, so we're using bpfcli to configure bpfilter chains and filtering rules. And we can do things on rule sets, which to my understanding is a sort of complete set of rules, and we can act on chains. And I think the chains and the rule sets get a little bit clearer as we see some examples. So we can do things like get and set these chains and the entire rule sets. And flush is used to remove. We've also got loading and attaching. And if you're familiar with eBPF, that's probably a very familiar operation, right? Because you load a BPF program into the kernel and then you attach it to some hook point inside the kernel. And that's exactly what we'd be doing with these chains. So I think we can think of a chain as corresponding to a BPF program, and then we're going to load that into the kernel and we're going to attach it. And we've got some examples here. You can create the chains and rule sets from either text files or from just strings. I think I'm just going to do it from strings. I haven't prepared any files. So to start with, we shouldn't have any rules defined, I think. So nothing appearing. So let's try creating, I'm going to start by creating a chain. When I ran that, you can see it tells us that it was processing a request from the CLI. So let's create a chain. Let's load it from a string. And you know what? Let's bring up the example. I think if I go to the usage page, I'll find an example. Okay. So we can see an example here that's got a keyword chain, a hook point. I think this is actually the wrong way around. I think it needs to be the keyword chain and then the name, and because I think here the policy is the name, I think, a hook point and accept, and then a definition of a rule that we want to match against. So this example, although I think there's something slightly wrong with it, is intended to match on ICMP packets and drop them. So let's try and create a chain. So I think I need to do my chain, and I'm going to start by attaching it to XDP. If that's kind of nice. I think I can just do accept now, just so I'm essentially defining an empty chain. Let's see if that loads okay. Okay, so that loaded, and you can see some interesting output here. It loaded, and it's got the hook being XTP, and the program itself is null. Yeah, Joseph is pointing out this is a very recent project. I think the idea of it has been around for a while, but it's really been picking up steam in the last kind of 6 months or so. There's been a lot of development on it. Right, so where was I? We've got this empty BPF program. I think it's also interesting to, need to be in the right window, look at BPF tool, actually. Let's look at the programs that are currently loaded. And actually we can already see, so there are the sort of default C group programs that get loaded on a machine. And then this number 36 here is, well, it's an XDP program. But if I do net list, I think is what I want. So don't actually have any programs attached anywhere in the network stack. And if I wanted to attach it, well, it's not going to do anything at the moment. So maybe it would be more interesting if I try and define a chain that actually does something. So how about I do rule, I think this should be right, IPv4 protocol. If I say that that's ICMP and I want to count those packets and I want to accept them, well, let's try that. Oh, okay. So I could, you know what, I'll just flush the whole lot for now. I think that should work. Okay. All right. So now I've got a slightly more meaningful program that's going to count, I hope, ping packets. So if I run that net list again, it's not attached to XDP yet. And I need to do this attach command. But in order to do that, let's just take a look at the interfaces on this machine. So I've got a loopback interface, I've got an Ethernet interface, and I've got, well, I've been running Docker on this machine at some point, so there's a Docker interface. This is the one we're interested in, number 2, which is the Ethernet connection that goes to the outside world. So if I want to attach this, think I need to do chain attach. And then I need to specify the name. And if I remember rightly, I called it my chain. And it already knows that this is an XTP program, but it needs to know what interface to attach it to. And I can do that, I think, like this. Okay, so that's attached my chain to the XTP hook points. And if I use BPF tool, I should now be able to see that. Yeah, we can see that's attached to the XTP interface for ENS4, interface index number 2. So that should, in theory, count ping packets. And I can see the output by looking at, I just basically dump all the rule set. We can see the counters are both 0, essentially. So it's currently had 0 packets on 0 bytes. But if I run some ping, let's ping Cisco. Okay. So that should be, what did I do? Five packets request and probably 5 response. So probably seeing about 10 packets. Okay, five packets because it's on XTP, so it's only going to look at the ingress packets. Okay, so we've got a rule. It's just counting them at the moment. Now, what if I were to change that rule to drop those packets? And let's, if I can find, there's the definition. So I'm going to change this to say drop. And the other thing I'm going to do is there's a nice option to update a chain. So this allows you to sort of update it in place. One thing we didn't look at before as I loaded them is you can see this bytecode that's been generated. So there's quite a lot of it, as you can see. We can see here it did the request a chain update from the CLI, and it created 154 BPF instructions in that program. Let's have a look at the program. Ooh, in BPF tool. Yeah, so that's program number 38 now. I thought that was, I know how many, I was hoping it was going to tell me how many instructions it was. Let's dump it. So dump the translated bytecode, and that is going to be EF frog. And if I scroll to the end, maybe this will look like it's the same code. Is it the same code? Yes. As far as I can see, going back, well, yeah. I'm going to say at least some of this looks the same. Okay. How many instructions? That's 153 and that is 160. So there is something slightly different there. But I think that's interesting. Let's have a look. Was there anything else? So what my speculation is, and this is, I can't remember which of these presentations I saw it in, but one of these scale presentations, there is, yeah, so there is this discussion of the BPF bytecode that's being produced. And I'm wondering whether the part of the program that we saw being generated in the debug output is essentially this rules part, and there's some common prologue, epilogue function. Perhaps that's my speculation. Okay, so let's bring this back. So if we remember rightly, at this point, we should have, let's get the rules. We should have a rule that's going to drop ping packets. At the moment, there haven't been any pings. Let's ping Cisco again. And well, presumably they are being dropped because we're not seeing any responses. We're not seeing any output from that ping command. So let's look at the rules. And yeah, it counted 11 packets as it dropped them. Okay, so that's quite cool. Where else can we attach to? Let's bring up the documentation, and yeah, okay. So the docs here are pretty thorough. They talk about all these the rule set options and the chain options. And let's get that out of the way. Don't know why it's decided to send that off to the left there. We'll just ignore that for now. Okay. So if I scroll down here far enough, I think we will find, yeah, some definitions of, okay, so a chain consists of a name, a hook, possibly some options, and a policy. This is why I think that example on the front page, I think it's got the name and the hook the wrong way around. But I think that's just a sign of how quickly this project is developing. And then if we come down here, we can see all the different hooks. So I've used XDP so far, but we can hook to other places, like we can hook to TC, either ingress or egress. The egress one's down here. There are these NF hooks, which if you look up information about IP tables and NF tables, they have these different hook points, pre-routing, input, forwarding, and output, and post-routing. And I guess the attachment points that bpfilter is using are, well, it's saying similar to. So I guess that's as close as they can find to where those hooks are in IP tables. Got a question here from Joseph. Do you think it will be possible to convert kubeproxy in eBPF with bpfilter? So I guess that's, could we achieve the same things as kubeproxy is achieving with bpfilter? I think right now, so maybe to answer that question, we need to say, what does kubeproxy do? Kubeproxy is taking packets destined for a Kubernetes service, and it's distributing, kind of load balancing them across the different pods that make up that service. So in kind of, let's say, traditional Kubernetes, that was performed by IP tables. Pretty sure there is now an NF tables implementation, like 99% certain that's true. And what Cilium does is, if you use kubeproxy replacement, it can use eBPF to do that load balancing instead. Can we do the same thing with bpfilter? I am not sure you can today, and I'll show you why. I think that the rules that we can define, so there's a matcher, it's sort of like, what are the characteristics of the packets that we're going to match on, and a verdict. And right now the verdicts are accept, drop, or continue. I'm not aware of a way that it could be forwarded, manipulated to change the destination addresses, for example, which is what you need to do when you're load balancing to a pod. So you're getting a packet that's destined for a certain service IP address, and you need to modify that so that it gets sent to and accepted by one of the pods that make up So I'm not sure that there is today an option to kind of rewrite the packet with bpfilter. Maybe that's a future idea. You put that into the issues on the project. I am also just going to say hi to Trap 7. All right. So what did I want to do? I wanted to drop some packets. No, I've already dropped some packets. We saw some ping. I'm wondering if we can change that rule so that it maybe only drops certain packets, maybe based on the address. Because we can see here, go down to here, match it, the matches. We can match on things like the protocol. You saw me matching on ICMP, source and destination port, source and destination address. There's some different options for IPv4 and IPv6. Okay, we can also match on some TCP and UDP. Actually, for UDP, it's just ports. I was going to say ports and flags. When I was trying this out earlier, I did put in place a foolish rule that dropped, was it all the packets? I think I dropped all the packets that didn't match source address. I think I wanted to, basically, I stopped all the network traffic between my virtual machine and the rest of the world because I dropped all of the packets from its IP address on that ENS4 interface. And that's a virtual machine in the cloud. So that meant my SSH traffic from my terminal here on my laptop to that virtual machine, all of that was being dropped. So yeah, I had to reboot the box. Kind of easy sort of mistake that you can make, and I have made many times, setting up eBPF rules on a machine. Okay, so what if we were to, well, let's first of all, let's try hooking to a different attachment point. Like we could hook to TC ingress and egress maybe. So let's, well, let's try and do set from string. I'm going to call this TC egress, and we're going to hook to TC egress, and let's accept. Let's first of all just put it on, count the ICMP packets. Okay. I want to do something similar for ingress. So that would be chain. Let's call it TC ingress. TC ingress. Oops, that's typo. TC ingress. So we should get some counters as we see packets in the network stack ingressing and egressing. But at the moment, those programs are not attached, and we can see that with BPF tool. Let's take a look. Okay, so that's our XDP program is still attached, but there's nothing attached in TC. So let's have a go at that. Attach TC ingress to option interface 2. Oh, I spelled that wrong. Very tempted to write BPF rather than BF. And we need to do the same thing for the egress one. TC egress. I probably should have just copied the line above, shouldn't I? index equals 2. Okay, let's have a look at the, yeah, we can see both of those programs attached now. So if we dump the rules set, yeah, we can see some new counters that have been added into that set of rules. Now, this is still dropping packets, right? So, and it's dropping ingress packets. So if I send a packet out, that should go through the TC stack and hit that egress egress counter. But so that should reach its destination, but the response is going to hit that that XDP hook first, get dropped, and so it should never reach that ingress counter. That's my theory. Let's see what happens. So we'll allow ping to run for a little bit so that it's sent a few packets. And we're not expecting them to succeed because we know that XDP is dropping the responses. And then if we look, I say XDP, the program attached to XDP. So there we go. We can see XDP has dropped, well, it had dropped some packets previously, so 23 packets that it's dropped. Since I added those TC programs, we've dropped 12 packets. So I guess my ping to Cisco had time to send 12 requests, and none of the responses were detected because they all got dropped by XDP before they hit this hook. All right. So what if we were to say, well, we'll only drop the packets that are, what if we were to drop packets to Cisco? So we can't ping Cisco, but we can ping something else. So if I go back in history, I can get the IP address here. Okay. So let's try and change that TC egress hook so that it will drop. Yeah, I want to try and drop packets that are sent to, I'm going to need to get rid of that XDP hook as well, aren't I? So let's try and do that first. Chain, I think I can do this. We want to get rid of my chain. Let's see whether this works. Okay, let's check what is attached now to the network interfaces. Okay, good. I've still got my ingress and egress programs, but I don't have the XDP program anymore. Okay, so now if I do the ping, we should see both of those counters incrementing. Oh, yes. No, they're not being dropped. They're just incrementing. And if I look at the output from the rule set, yeah, we're seeing, we should see those counters going up. Let's do it again just to prove that they are going up. So it was 19 and 7 before, and now it's 24 and 12. Okay, so that's good. Right, I want to try and make it so my pings, my egress pings are going to get dropped if they are to Cisco. So what do I need to do? Well, chain update. This is TC egress. I think I need to do the from str thing. Okay, so TC egress, and it's still attached, or we still want it to be attached to the TC egress point. I am not sure whether I need to specify that interface index here or whether it would just update anyway, but well, let's try it like this. So we want a rule that's gonna match on ICMP. That equals ICMP. And we also want to match on the destination address. Okay, so if it's a ping packet to that address, I'm going to count it and drop it, I hope. Okay, hook options are ignored when updating a chain, but I think it's still going to be attached to that. Let's check. Yes, I think we've replaced the egress program with the new one because we did the chain update. Okay, so let's look at the rule sets. Okay, the egress hook right now doesn't have any packets, but we can see it's matching on not just the protocol equaling 1, which is the value of the value that identifies that it's an ICMP packet, and I'm going to guess this is the hex representation of that cisco.com IP address. So we should find that if we ping Cisco, where's that gone? This shouldn't work. So those should be dropped. And let's see what happens if we ping isovalent. And that is working. Those packets are allowed to pass, and we can see the counters. Yeah, so we dropped 7 packets on their way out because they matched Cisco's IP address, but we allowed other ping packets to pass through just fine. Okay, here's an interesting question. I'm assuming we can also write this long chain of commands in C, right? Well, yeah, you could write the eBPF program directly. Yeah, so you could essentially get this, you could write the C code that translates to this bytecode. So you could do that. This is probably easier. Maybe that's a good topic for a different eCHO episode. All right. So far, this seems to be going pretty well. Nothing really bad has happened, and I haven't completely blocked access to my virtual machine, so that's that's good. Endo saying thank you. Of course, you're welcome. If you've got questions or something specific you would like me to try and do, now would be a really good time to enter those. And I'm going to just have a quick look at what else there is in the documentation, whether there's something that we want to explore a bit more. I guess one other thing that was kind of interesting to me, because my virtual machine is connected to the internet, while I was testing this out, I had some kind of rule that was doing a counter on ping packets, and I was finding it actually was incrementing even though I wasn't sending ping traffic. So I was kind of a bit suspicious of that. And it turned out, using TCP dump, I could see, oh, I was receiving pings all right. It was because my virtual machine is connected to the internet, and obviously that just means some random explorers out there ping the IP address from time to time. So that explained why I was seeing these kind of slightly mysterious ping packets. What else do we want to look at? So maybe there's some interesting things here in the program generation. So the BF program, this is part of the developer documentation. So this is sort of details of how it's been implemented. So there's some generic context. There's pre-processing the packets headers. So that's going to be pulling out things like the protocol byte that we looked at. So that value of 1 that matches ICMP, for example. executing all the rules, applying its verdict, and returning, and apply the policy if no rule matched. So that explains why, if we look at these rules, there's this accept here is essentially saying, if you have a packet that doesn't match the rule, accept it. So we could have this the other way around. We could put drop here and say, if you have a packet that doesn't match the rule, then drop that packet. So it allows you to do kind of default deny or default accept, I suppose. Okay. Packets are pre-processed according to the program type. So the program type is going to be related to the hook points. You have a different program type for XDP. You have a different program type for TC. I'm not actually sure what program type you get for those NF hook points, but I think there is some additional. I think the context is different there. This is pretty cool. The protocol IDs must be stored in registers and not on the stack, because older verifiers can't keep track of scalar values located on the stack. That's I think an interesting sort of comment on how the verifier has improved over the years, which is pretty cool. Ende is asking, will this be included in my BPF GitHub repo? I'm going to say no, because there is a fabulous repo that already exists. Let's see if I can show it to you. I should probably have shown you this already. So this is under Facebook bpfilter. This is the repo. As you can see, there was a release a couple of weeks ago. I think it was this release being announced that was the reason why I saw bpfilter in, sort of past my consciousness. This has, is this the same animation? I'm going to guess it probably is the same animation we saw on the website. And a bit more information about building. Like I said, the building was super easy to follow and deal with. And yeah, an example rule. So that's very similar to what I'd shown in my example. So yeah, if you are, if you want to try this out for yourself, you can pull it from there. And I'm going to guess, issues and PRs are also probably welcome. Speaking on Quentin's behalf there. Actually, something also I thought was quite interesting. I had a little look, when I was looking for some examples, I had a little look at these end-to-end tests. And was it this one? Yes. So I think this is pretty nice. This is a bash script, as you can see. And it's running a series of tests, sort of, well, end-to-end tests. It's exactly what it says on the tin. And you can see here, it's defining host IP address and a namespace IP address. And what it does further down here is set up. So if you have ever seen my containers from scratch, or if you've read my container security book, some of this might look really, well, it's not exactly the same, but it's the same kind of process. So we're doing things like adding a network namespace so that there's going to be like a separate network stack, or separate representation of the stack. There's going to be running on the same virtual machine. It's going to be like a container. It's effectively is a container, and then having a virtual Ethernet connection between the host and that container to run tests on, to check the that BP filtering is working as expected. So we can see things like it's going to bind the directory for namespaces so that that can be mounted into this unshare. So unshare is a way of creating new Linux namespaces, and this is essentially what happens when Docker creates a container for you, or when containerd creates a container for you. So it's got its own user namespace, its own mount namespace, its own network namespace. And yeah, it's also able to mount BPF programs into a BPF file system. And then you can see here, it's creating the virtual Ethernet connection between the host and that namespace, and creating the IP addresses, and then bringing up that link between the host and the network namespace. So I think that's pretty cool. I haven't actually tried running these tests, but it was nice to see that. And then you can see there's some sort of framework here about how the test's going to work. And then you start seeing these test suites, and you can see things like testing whether or not you can, with a rule that drops. This is exactly what we were just looking at, right? This is an XDP hook attached to the interface and dropping ping packets. So this was quite a useful resource for having a look at some rules, and to understand the format and the syntax of those rules, and how they could be used in sort of real life. Okay, so now we've looked at the test suite. I will point out that we've got some show notes on HackMD. There, no, other side. Not sure which side. Somewhere in the corner, that side, I think. Show notes on HackMD, and you'll find there the links to that bpfilter website that I showed you, that GitHub repo that we were just looking at, Quentin's website, where he's written some updates about the state of bpfilter and like the future aspirations for it. So that's kind of interesting to see. And also the slides from, he's actually spoken about this twice at the Scale conference. Something apparently went wrong with the video recording for Scale 22, but you can find the slides for that, and also take a look at the video there. Joseph asking, was Quentin available? Yeah, really unfortunate. I think I mentioned at the start, we kind of had a realization only a couple of days ago that we needed a topic for today's show, and Quentin unfortunately couldn't make it in time. But as I said, he was super helpful, answering some of my questions so that I could understand what's going on here a bit better. Yeah, so maybe in a future episode, we'll get Quentin on to talk about this in person. That would be really cool. Okay, unless anybody really quickly types any questions or has something else they want me to try and achieve with bpfilter, I think we can call that a successful exploration. I'm super interested to see how this, how this project grows and what people do with it. Really interesting as well to see things like IP tables being implemented or being improved on by having an eBPF implementation. So I'm pretty excited about that. So with that said, I think for those of us in the UK, we have a long weekend coming up, and I think folks in the US might as well. Thank you, Joseph. That's very kind of you to say. That's great. So yeah, I'm just gonna call it a day there and wish you all a really great weekend, and a really great long weekend if that's what you have in store. Bye for now.